for another circular motion problem. This one involves a horizontal circle and the conditions which result in artificial gravity. A device for training astronauts and jet fighter pilots is designed to rotate a trainee in a horizontal circle of radius 14.0 meters. If the force felt by the trainee on her back is 8.75 times her own weight, how fast is she rotating? Express your answer in both meters per second and revolutions per second. So we've got a horizontal circle here, so I'm going to draw it on a bit of an angle. Okay, so there's our horizontal circle. The radius of that circle we'll call R, and the trainee is being whipped around. Okay, so let's say this right here is the trainee. Okay, she's going in a certain direction. Okay, we'll say that her speed at that instant is V, and we are looking for V. Okay, so how fast is she rotating? Okay, that blue represents her, and there is a centripetal force going towards the center of that circle. Okay, so that's also going to be an important factor. So my radius is 14 meters. We're told in the question that the force felt by the trainee on her back is 8.75 times her own weight. That is the centripetal force acting on her. And it's 8.75 times the force of gravity, because weight and force of gravity are indeed the same. And we are looking for speed. Okay, so we are looking for speed. So we're going to go ahead and use Newton's second law in circular form. So Fc equals MAC. Okay, so Fc we know is 8.75 times her weight. Okay, equals MAC. Now let's rewrite this a little bit simpler. Fg is also known as mg, and acceleration centripetal is v squared over r. Okay, this is nice. This is why you weren't given mass in the problem, because they were expected to cancel out. Now we're looking for v. So rearranging this formula for v, multiply both sides by r, and then take the square root. And I'm just going to go ahead and write v on the left side here. So v is equal to the square root of 8.75 gr. Okay, so plugging in your numbers, square root 8.75. G is your usual 9.8 meters per second squared. And the radius of the circle we're told in the question is 14.0 meters. When you plug that in your calculator, you're going to get V is 34.6 meters per second. So that's our answer in meters per second. That's half of our answer. We also have to give it in revolutions per second. Okay, so think of it like this. When the trainee goes around the circle 1, that's considered a revolution. Okay, so 1 revolution means she travels through the distance of 1 circle, which is also known as the circumference. Okay, so 1 revolution is equal to 1 circumference of the circle, which is equal to 2 pi r. Okay, so circumference equals 2 pi times r, which is 14.0 meters. Okay, that comes out to be 87.96 meters. Now, take what you're given. Okay, we know that the speed is 34.6 meters per second. And we're also going to multiply this by 1. Okay, remember your empty fraction. 1 revolution is 87.96 meters. Right, so I've got meters per second here. I've got a meters in the denominator there. So the meter is going to cancel out with the meter, and I'm going to be left with revolutions per second. Okay, so 34.6 divided by 87.96, you get V equals 0.393 revolutions per second. And it's fine to leave it to 3 sig figs. After all, that's what we're given in the problem. So there you have it. There are your 2 answers, your speed in meters per second and revolutions per second. Guys, I hope this was helpful. If it was, be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. Enjoy the rest of your day, guys, and I will catch you in the next video.